Our song today is Who Can It Be Now by Men at Work. And our topic is absolute value functions. We're going to graph and write equations of translations. So first of all, a definition of an absolute value function is pretty self-explanatory. It's a function with an absolute value. Couldn't figure out how to define it without using those terms. The parent function. A parent function is the simplest form of any equation. So the simplest form of an absolute value is absolute value of x. A translation, hopefully you remember working with translations in geometry. Translation is shifting. You probably took triangles and shifted them on a coordinate plane. We're going to be looking at shifting functions. So an up or down shift is normal. It's outside the asylum. Think back to our Batman clip that we watched. So if you see a plus k, it moves up. If you see a minus k, it moves down. The left or right shift is inside the asylum, so it's not normal. So if you see an x minus h, that's a right shift, and x plus h is a left shift. In order to translate our graph, we need to know what our graph looks like. So we're going to start by plotting our parent function. Make a little t-chart. And this will be the last t-chart we make, because then once we know what the parent function looks like, we can just move it around on the coordinate plane. So absolute value of -3 is positive, absolute value of -2, and so on. You guys know how to take an absolute value and fill out a t-chart. And then we'll go ahead and plot our points. All right, so notice with this graph, you might be thinking it looks kind of like a parabola. Hopefully you're familiar with parabolas. Except for, instead of a U shape, it's a V shape. So it's got a sharp point at our vertex. So the vertex is where the graph kind of flips and heads off in a different direction. And I want you to think about why this is the case. So think about if we dropped the absolute value and we just had f of x equals x, our line would extend back this way. And that's off a bit, I know. But the absolute value makes those y values positive, which means it flips it or reflects it up over the x-axis. The other thing I want you to notice is the slope of each side of our v. So off to the right, we're going up 1 over 1, up 1, right 1, up 1, right 1. So our slope is +1. And off to the left, we're going up left, up left, up left. So our slope is -1. So we're going to use the vertex and the slope of either side to translate our parent function. So our next example is to translate the parent function 3 units left and 2 units up. And we also need to write the equation. I'm going to start with the graph. That tends to be a little easier. So thinking about the vertex was at 0, 0. So I'm just going to go ahead and shift the vertex, or 0, 0, 3 units left, 2 units up. So here's my new vertex. And then remember the slope off to the right was +1, and the slope off to the left was -1. So we got our nice V shape and our relatively straight lines. To write the equation, I'm going to name it differently. F of x is our parent function, so I'm going to call my translation g of x. Remember, our vertex now is -3, 2. The horizontal shift goes inside the asylum, and it's not normal. So it becomes an x plus 3. The vertical shift is outside the asylum, and it is normal at a +2. Last example is writing the equation from the graph. So as you may have guessed, all we need to do is identify that vertex. And once we have the vertex, we put the horizontal change inside the asylum, opposite of what you think, and the vertical change outside the asylum, and it looks normal. Next, we've got the U-tries. And the assignment for this is a little bit different. If I haven't already given it to you, I will make sure to do so in class.